Okay, in this video we're going to be doing problem set 23 from Calc AB, problems and a playlist in the description below, and let's see what the problems look like. Find the equation of the line tangent to tan of y equals x squared at -1 pi over 4. So this is implicit first to find the slope, and then we'll just write the tangent line in point slope form, obviously. So let's see. I got to find the derivative with respect to x of both sides of this thing. This is interesting because there are functions on both sides. Often it's just set equal to a constant, but both sides. All right, derivative tan of something is secant squared of that thing times the derivative of that thing. The derivative of y is dy dx. And then obviously the derivative of x squared with respect to x is just 2x. So I'm going to solve for dy dx. You don't really need to. You just need to like sub in at this point. I'm going to do it anyway. So dy dx is going to be 2x over secant squared of y. You might have chosen to write it as 2x times cosine squared of y. That might actually be easier depending on how you think about these things. I need to evaluate this at -1 pi over 4. And so I'm plugging in everywhere I see an x, it's going to be -1. Everywhere I see a y, it's going to be pi over 4. The secant of pi over 4 is root 2. So if I square that, I just get 2. So I have -2 over 2, which is -1. And then my tangent line in point slope form, y minus pi over 4 equals -1 times the quantity x plus 1. Good problem. Next up, determine if x times y squared plus x squared equals 0 is concave up or down at -1, 1. So we're going to need the second derivative. And like, will this be messy? I don't really know. So here goes. We're going to find the derivative with respect to x of both sides. So x times y squared requires the product rule. So we're going to go x 2y dy dx plus y squared times 1, and then just plus 2x. Derivative of 0 is obviously 0. I am going to solve this for dy dx because I want to find the second derivative, and that's how I choose to do it. So dy dx is going to be -2x minus y squared over 2xy. We need to find the second derivative, and I think it's actually easier if I break this up into two fractions. So I'm going to make this -1 over y and then -1/2 y over x. I think that's going to be easier to deal with. So the second derivative. All right, so it's going to be the derivative of the first derivative with respect to x. So the derivative of -1 over y, or -1 times y to the negative first, is going to be 1 over y squared, but then times the derivative of y, so times dy dx. And then for the second part, I actually need the quotient rule, so it's -1/2 the quantity, bottom, derivative of the top, minus top, derivative of the bottom, all over the bottom squared. That's kind of ugly, but I don't need to simplify it. I just need to evaluate it. I need to evaluate it at the point -1, 1, which means I do need to know what dy dx is at -1, 1. So I'm going to go back and find that. So at -1, 1, this thing just gives me -1 plus 1/2, which is -1/2 overall. All right, so I'm trying to evaluate the second derivative at -1, 1, where dy dx is also -1/2. I don't really know the notation for that. You don't see people write it very often, but that's what I'm doing. I think that would be fine. So every x is -1, every y is 1, every dy dx is -1/2. Plug in, it looks like this. Now, we just need to figure out if this is positive or negative. We don't actually need the value. So this, you could look at it and be like, this is -1/2 times just 1/4, which is definitely less than 0. And so we can answer the question. This thing is definitely concave down at the point -1, 1. Pretty good problem. I mean, you do find yourself finding the second derivative specifically to answer those questions about concavity usually. Or multiple choice, I guess. Not really that common. All right, next question. Find dv dt given that dv dr is 8 and dr dt is 3. So we've seen this concept a couple times. It's basically the chain rule, right? dv dt is going to be, if I start off with dv dr, I'm going to have to multiply by dr dt to kind of get those drs out of there. So let's see. I'm going to set it up. dv dt is dv dr times dr dt. That's the chain rule. And then we just no values. So this, I don't know. This problem kind of scares some people, so I'm throwing it in, but obviously, once you get the idea down, not that bad. All right, so we get 24 as our answer here. That's this entire problem set, not a bad one. Hope this was helpful, and good luck.